ఎవరు? Sir, can you make me the host, sir? Sir?
Oh, yeah.
Sure. Yes, sir. If you can make me the host, that'll be great.
Regarding for what?
I have to let in 2 people, sir, as a panelist.
I will make you the co-host, no problem.
Sure, sir.
Already panelists are there, no?
No, sir, we have 2 more people. They weren't sent the invite, so.
Yeah, you can. You continue.
We'll just wait for 2 minutes and then we'll start the webinar. Thank you. First of all, good morning, everyone. So I welcome everyone present here to SRMECell Signature Guest Lecture Series. Today, we have a very special person who will be introducing very soon. But before that, I shall give a small brief introduction about SRMECell to all of you who have joined for the very first time. So SRMEP Entrepreneurship Cell is one of the most vibrant student communities in Andhra Pradesh. It impacts hundreds of lives and societies through its various teams, trained in specialized knowledge and expertise into knowledge, innovation, leadership, community building, creativity, pioneering initiatives in association with the government, the corporate, and the other institutions. So the Entrepreneurship Cell, SRM University, is a place for all who think differently and who want to avoid, taking the beaten paths and believe in leaving trails in life, walks of life. So overall, we have around 8 different communities and various initiatives working in alignment with the true spirit of innovation and leadership. And at Inventors Village, we play a major role of at ESEL. And here we aspire to develop solutions to real world problems, making industry ready products. So students are the greatest natural resource and the cell intends to nurture them and provide them with all the opportunities for excellence. It intends to pioneer the corporate world and would basically help the students get in touch with the corporate, and if they have an idea, we help them make it into a product. So now, without further ado, I would like to ask my co-host Sunil to introduce the guest of honor, Mr. Jairam Kolipar.
Thank you, Naveen. Good morning, ladies and gentlemen. It's a great pleasure for me to introduce our today's speaker, who is going to deliver a talk on recommendation systems in real life. To say about his profile, he is originally from Vijayawada, where he studied up to 12th standard. Subsequently, he joined Amrita University in Kerala to pursue undergraduate in the field of electronics and communications. which he successfully completed with distinction and received great applause from the university. After completing his undergraduation, he worked for Huawei as a software engineer, and later he moved to Juniper Networks as a system test engineer. After 3.5 years of industrial experience in India, he went to Milan, Italy to pursue master's degree in telecommunication engineering with a specialization in artificial intelligence in Politecnico di Milano, which is one of the premier institutes in the world. During his master's, he managed to get knowledge both from system and technology aspects of telecommunication scenarios, and also successfully learned and developed an interconnection between telecommunications and data science domains. After completing his master's, he is now working for iGenius.ai as a machine learning engineer, where he primarily deals with recommendation systems in the product Crystal, which they built. Now I am requesting Mr. Jairam to start his talk on the same. Mr. Jairam sir, you can continue with the presentation.
Yeah, thank you, Sunil, and thank you, Sainavin, for the great introduction of your investors Inventor Village and the great vision that you guys have. I completely appreciate it. Good luck for you in that particular regard. So I quickly start. Just a second. Okay. Okay. Can you see me right now? Okay, great.
Yes, yes.
Yeah. It's actually 5 o'clock in the morning here, so it's pretty bad. So yeah. So I'll quickly move to the presentation now. Meanwhile, while I'm presenting, I'm going to turn off my video and then I'll turn on for the Q&A. Okay, if that's okay. Good.
Sure. And thank you for doing this in the morning itself.
Yeah, I realized that today it's daylight saving switch in Europe. So we go 1 hour behind the original timeline. Okay. Let me share my screen. Okay. Do you see the screen and is it in a right size?
Yeah. I'm good.
Okay, thank you. So let's switch. First of all, thank you. Thank you for joining. Welcome everyone. Wherever you are, thanks for joining. My name is Jairam Kollipara. I'm a ML engineer at iGenius.ai. Today, I'm going to present you the idea of augmented intelligence and how we achieve with our amazing digital advisor, Crystal. So I'm going to talk about specifically on recommender systems. This is one of the booming applications of AI and ML in particular. And we're going to start this way. I'm going to give you a short introduction of mine, who I am, where do I come from, and why am I here. And then we're going to look into our product, which is Crystal. We're going to give us a very slight introduction about this digital advisor. And then we're going to talk about the application of recommendation system here at Crystal and how does it work and how we actually make use of this particular knowledge. And then in the last half an hour, 20 minutes, I'm going to leave the floor for Q&A. Any questions stood up, I'll going to answer it. It can be with respect to the presentation or even off topic. Should be fine. Okay, as a great introduction given by Mr. Sunil, I'm quite happy that somebody has given a very nice introduction to me. I have completed my bachelor's from Amrita Vishwadyapitam. It's in Kerala. I think you guys might be aware of this particular university. I was graduated in 2014 from Electronics and Communications Engineering. Later then, I had a chance to work on VoIP, which is Voice over Internet Protocols. I was pretty much working on one of the protocol on the internet, which is basically SIP, which is called Session Initiation Protocol. So for example, this particular Zoom call, in order to set it up on the network, we basically use a protocol called SIP. I worked on that particular protocol, and then I moved to Juniper Networks as a network engineer. I had a chance to work on routers and switches. Okay. Could you please mute someone who's talking? Okay. So and then it is where in Juniper Networks where I had a chance to work on the ML part. This is a very interesting story which happened. So we are working on a network, and our goal was to predict the network failure. So you have a network, and there are links in the network. I hope you understand this term. For every point between a router and an router, there are links, a network link. So we need to predict whether the link going to be failed in the next couple of days or couple of weeks, basically draw an estimate out of it. So this happens basically studying the network, understanding the packets, the nature of packets that are being transferred from point to point, all this stuff. So all these things was happened during 2016 when the AI was actually taking a stand in the industry. This is when I realized that I needed some more skills in order to dig deeper into this particular domain and understand how ML or AI actually impacts the industry. During 2017, I had a chance of a full scholarship. It's called Invest Your Talent in Italy from Foreign Ministry of Italy, wherein they offer you a full scholarship, plus they give you a stipend of around 1,100 euros, which is basically, it's like a salary here in Milan. So it was a pretty much win-win situation for me. I was actually looking to have a level up in my career. So I chose to move to Milan in 2017. And by 2019, I finished my master's here. I had a chance to work with Vodafone in order to predict. The project was this. I have to predict the churn prediction of the Vodafone users in Italy region. So we have made the data collection. We made all the parameters that are required for us to monitor it. For example, on your cell phone, you would see RSSI value, which is a signal strength. You would also see what is the uptime and downtime of your service. You would also monitor the internet speed, correct? So all the things that make a customer annoy about the service were actually taken care. So this is when I applied a full-scale machine learning algorithm or artificial intelligence domain onto the networking and telecommunications field. This is when I mastered the skills of machine learning, what are the various branches of it, and how actually the industry works on. Later in that year, I had a chance to work with, actually before joining machine learning engineer at iGenius, I was a freelancer working for companies in Belgium and Germany, solving their ML problems. So NLP was one of the key aspects that I actually focused on. I also focused on computer vision. I had basics from computer vision from the university itself, and the NLP was actually I studied during my master's. So this particular slide, I want to shed light about, I think majority students here are ECE. The panelists told me that you have a question about how the ECE guy turned into an MLE engineer. I'm going to shed light about these things. I'm going to present my view. So the best part of ECE, that what I think is this particular branch focuses both on hardware and software. Why do I say this? You have MATLAB, wherein you actually program things to visualize and operate and make actually computations. On the hardware, you have electronics, circuits, you talk to the oscillators, you monitor signals, you create logics using gates and all these things. You have a combination of these two things. My focus during my engineering was on the communications engineering. Especially, I was focusing on signals and systems, DSP, wireless networks. I hope you also have the same subjects. The engineering might be evolved by this time. It's been 6 years for me since I did this. Image processing interested me a lot. As you know, image processing is also a part of computer vision. In fact, my thesis was on stereo vision. My thesis at Amrita was on stereo vision. What we were doing, we're actually creating an algorithm called SLAM, simultaneous localization and mapping, localization through GPS, and the cameras. So this was our task to combat. So this is when I realized the need of being good at programming. In my course curriculum, we never had a programming course. I barely had skills on C language and Python. I have actually minimal knowledge on them. On the other side, what it takes to be an ML engineer? To be honest, ML is a generalized subject. You can't actually say that only computer science students can become an ML engineer. I have colleagues who have come from mathematics, who have come from physics, who has come from biomedical engineering. They do ML engineering. ML engineering is all about mathematics. It's all about having an engineering mindset. It involves logical thinking and coding skills. As I said, computer vision is an extension of image processing that you've already studied during your bachelor's. I guess if you are in ECE, you would have chance to have this particular elective in your course curriculum, maybe. The most interesting thing is the time series analysis, which is now currently a very strong application in ML field. Time series analysis is an extension of signal analysis. Signals are basically points ordered in time, correct? So time series analysis is basically that. For example, look at the stock market prediction. Stock markets, they change over time. This is basically a signal coming from Bombay Stock Exchange on particular stock. You basically monitor these signals, and then you're going to predict them what's going to happen in the future. So all the transformations, convolutions, filtering, Kalman filtering, all these things that you learn on your signals and systems, you basically apply here. So do you see the connect? Of course, there is a connect. So for us, it is much more easy to become ML engineer compared to mechanical or EEE guys. It's a bit difficult for them. So I've been working with this startup called iGenius. It's Italy's top 10 startup. So what are the major benefits of having to work in a startup? So in India, I had a chance to work with MNCs, Huawei and Juniper Networks. They're well-established companies and they offer you a lot of money and they give you a lot of benefits during your work. But unlike in a startup, we work on a minimal team. You may or may not have a good infrastructure at the company level. But what you'll have is you work on the newest technology. You hit the market where it is required for the engineers to basically solve this particular problem. You are as I said, you are the one of the first ones to define a solution for a problem in the market. Your skills make an immediate impact within the company. Your voice is heard, and you find young people around you, loads of fun. These are the major changes that I've observed from an MNC to a startup. I would suggest people to look for an opportunity in startup, though they pay less initially, but the exposure and the level of confidence that you get in your life is immense. It is a no match with the corporate job that you're gonna get in future. Okay, what is the problem? As I said, we solved a problem at iGenius, right? We solved this particular problem. You have a hell loads of data out there. These are some statements from McKinsey and Gartner. There is hell loads of data and a lot of people are data illiterate. Even the engineers and big companies, they have no skills on their data literacy. And McKinsey says that if we are able to make use of the data that we have, we're gonna multiply businesses' revenues by 23 times, which is immense. We do this. We basically solve this problem. We make the data talk. What do we have an answer for this? We have augmented intelligence as an answer. Between AI and the AI. So AI is an artificial intelligence intended to replace the human intelligence or workforce. It's fully automated stuff. Augmented intelligence, on the other hand, is basically a complement, not a replacement of human intelligence. You basically work along with the systems. Your systems and the systems that you develop are basically an add-on for the users or the clients that are basically using our product. So we have our product, which is called Crystal. It's a virtual advisor for data analytics. I'm going to play a video now, just to give you a glimpse of what we do. Let me know if the sound is not audible, okay? Or if it is audible, just don't say anything. I'm going to play it.
You and your business data need to talk. To get answers, just ask. Watch this.
Tell me about product revenues.
The personal accounts performance went up by 12%, and the savings accounts went down by 2%.
Knowing anything else is as simple as saying, anything else?
I think this will interest you. The business accounts revenues are forecast to go down next quarter.
For the first time, you can talk to your data like a person, a smart one that keeps you updated, gives you next steps that matter, and works with you to get things done right.
Last month's lead conversion rate was 6%, down 1% from the month before. Why not set up a meeting with your sales team? Okay, reminders set.
See, we don't just make data talk, we make it human, superhuman actually. Here's how it works. The natural language processing labels the query and understands what you need. Then the system uses a business knowledge graph to look for, correlate, and identify data sources. The fast data retrieval executes the query, collects and normalizes the data, and streams it. Next, it decides how to show it, builds the reply, and related suggestion tips. Did you get all that? You don't have to when it's so simple. It's time for a different type of data interaction. It's time to hire Crystal.
Yeah. So what did I just see? A chatbot or a virtual assistant? You would have already in your current daily life, you would have already saw a lot of chatbots in if you visit any web page these days, they have a chatbot popping up in the bottom right corner. So these are basically a text interface and relies on the structured dialogue. They answer you some sort of already pre-designed questions, and if you do not match them, they basically forward your request to the operator who is behind it. So what's a virtual assistant? Famous examples: Siri and Alexa. So Siri and Alexa, they talk to you, they answer your query, they make all the steps. But what's problem with Siri and Alexa is they're not proactive. If you want to listen to a music and you feel very romantic about yourself and you want to listen to romantic music, and then Alexa doesn't come up saying that, hey Jay, you feel to be more romantic now, why don't I play you some Shah Rukh Khan songs? It doesn't say that. We actually have to invoke the system and asking for it. But on the other hand, the Crystal doesn't play you music, but it monitors your data and comes up with all these proactive nature. For example, it learns from the data and the user behavior. It gives a predictive advice in real time. It delivers a proactive notifications, maintains consistency across the channels. There will be another video now, which basically answers this particular thing.
Why choose an advisor instead of a chatbot for your business data intelligence? A chatbot is just a part of your infrastructure. It has no direct data connection, is based on a fixed set of questions, and limited in its language recognition. An advisor captures all of your infrastructure, integrating with all your data sources in real time, recognizing natural language, and learning from you and your business data as you use it. So say you want to ask, show me UK total sales. A chatbot stays on a static preset flow and doesn't understand context. An advisor adapts to your business context and generates the flow based on data with a business knowledge graph, like you're talking to a real colleague who gets your needs and your business. And what if you asked, what's this month's new business? A chatbot only works when you start it. An advisor monitors your data 24/7 and tells you if there's anything you should know, guiding you to the right decisions. An advisor will change the way you do business, and there's only one. Her name's Crystal.
Okay, so those are the set of videos which I want to show you guys, so you have a a basic understanding of how our system works. So internally, on the technical aspect, what do we actually do is natural language processing. We understand the language both in text and both in speech. So this comes under an AI field called conversational AI. You can actually Google it out and see what are the papers behind this. Google is actually making a lot of research in this particular field. Here in Europe and I think even in the US, the conversational AI is being taken into a very serious note, and there are a lot of research and a lot of companies that are coming up to solve this business problem. So, for example, on your left, you see a mobile screen screenshot. You actually see 3 colors, which is green, violet, and blue. This is basically a text, which is this. If the user asks you, show me the sales in the UK for the last month, we basically understand the intent of the user, which is one of the process in the natural language processing, in order to understand the context of the user. Okay, so we understand, we extract these objects, whether it's what timeline is asking, which is a location that is specified up, what kind of metrics is actually looking in, all these things. As soon as a user integrates this data to our system, we basically invoke something called business knowledge graph. This is basically, in crude terms, we understand an interaction between one KPI to the other KPI. So what is this? For example, one of the KPI is let's talk in SRM. I mean, let's make an analogy in the SRM university. Okay, if consider signals and systems is one of your subject, and digital signal processing is one of your subject. So you guys know that signal systems and DSP are related. There are some topics which are an overlap on these things. People who have performed in signal systems, they tend to perform good in DSP. So we basically make this connection as soon as we have your marks or we have your information about your curriculum that we see. We work on the fast data retrieval. We have indexing. There's a lot of background stuff, which apart from this is not the AI part, this is more of a backend team part here. And then we actually do a dynamic data representation. That means you can hover on the screen and you can actually speak and visualize strongly on the data set that's being visualized. I'm going to quickly run through these particular talents, which is basically what are the add-on features of Crystal. We understand the context. As I said, we give suggestion tips. So what are suggestion tips? Suggestion tips are basically recommendations on the user behavior. We stay ahead of your thought process. We consistently monitor your data. We do a real-time processing. We monitor your historical data. We come up with some sort of insights. For example, anomaly, if there is an outlier that is being detected. Is there a chance of attrition rate in your company? What is there an alert that you want to set? All these things. Having said the possibility of setting an alert, a user can actually say that, okay, tell me when the sales go down by 3% as of now, or 5% as of now. So we're going to set an alert here, and as soon as it is not just one point, we're going to monitor a couple of signals coming from more than one point in time in the signal, and then we monitor whether the 5% is actually true or not, and then we come up with a notification, as you see on the right. As you know, these days the dashboards are something pretty fashion. So we also provide a dashboard. It's a drag and drop customization. You actually can convert the entire dashboard into your Excel sheet, and then the businesses makes easy for you. So advisor is a part of NLP and signals and systems there. But on the other side, we have dashboard, which is pure data, data visualization part. So let's move on to the suggestion tips. I mean, from the poster that you have solved today, how our recommendation systems work in Netflix, Amazon, or any famous e-commerce website that you see here. They all follow a simple process. Well, they started with simple, but now at this level, they are pretty complex. We have implemented a similar sort of recommendation systems here at Crystal. We call these assertion tips. So what is basically a recommendation? So the next slides are going to be a knowledge about how a recommendation system is and how do we actually build it and how do we evaluate it in real life. So recommendation systems is basically an information filtering system. You have, let me make an example in Amazon. You have a lot of products, and there are some products that are very much interested to you, and I want to see only them. So that's basically you're filtering the entire product space on Amazon or an entire movie space on Netflix. And in Crystal, you have filter out entire topic space. Topics are basically the items that we, to put in Amazon analogy, we sell items. We sell topics to the user. So any recommendation systems has this particular architecture. You have candidate generation. That's what filtering from the large corpus of items to few items. You score them, you pick the top key items. It depends upon your business case, how many recommendations you want to make. You want to make 1, you want to make 2, you want to make 100. The K takes that value. I re-rank them. Additional constraints are added here to take into account. For example, Amazon may not want to show you the product that you have already bought. Netflix may not want to show you the movie that has interested you a lot, but you do not want to watch it again in the less time, right? You want to re-rank all these things, and you want to keep that particular preference down in the list. So basically, why do we need this? This is a highly scalable feature. It can serve millions of users at the same time. The algorithms that are behind recommended systems are quite powerful. One of the famous is matrix factorization, which is like boom. It can scale up to a lot of users and a lot of items. You have user satisfaction and retention prediction. Basically, you can measure. What am I trying to say here is you can measure how much user is interested onto the system. If a user clicks more onto your system, you get more signals from the user time to time. You monitor them, you understand that the user is actually liking the system. So you keep that feature for the user. If the user, vice versa, doesn't like the system, you may not have much activity on the system. So recommendations are not useful. We want to make the recommendation more stronger. Of course, the revenue. Netflix gave a statement in 2017 that their streaming platform with the recommendation system has gone 80% up in their revenue, and Amazon told they have 30% up in their revenue. So how do we actually achieve this? There are two important recommendation system methodologies in literature, which is content-based and collaborative filtering. These are very legacy. Any recommended system that you see, if you have to start a recommended system to build a recommendation from scratch, this is a point that where you start. You do content-based filtering, you do collaborative filtering. So what are these two? The content-based filtering is basically addresses the cold start problem. I'm going to explain what it is in detail in the next slides. Collaborative filtering is basically works along with the other users in the system, and how about acting together rather than acting in a single shot. User embeddings. This is one of the very Crystal thing. We have developed this particular architecture here at Crystal. We are actually writing a research paper about this. So we have text, right? We're going to make use of the text, and we're going to make recommendations in the conversational AI space. So this is more of a Crystal thing. You have advanced algorithms. I'm not gonna dive deep into this particular thing. It's a pretty much advanced topic. You guys can have a look after this presentation. So as I said, what is content filtering? Content filtering purely relies on the products that you're selling to the user. For example, You don't need any user to give a feedback or preferences about a product. You have a list of products and you want to rank them in order. Content-based filtering is basically this. So as soon as, if I hope you guys have a subscription to Netflix. If not, when you actually sign up on Netflix, Netflix asks you, okay, what are the genres that you really like? Maybe Telugu, English, Hindi, and then the languages and the genres. You basically say, okay, I love action movies, I have romantic movies, I love political drama, all these things. So Netflix gets you a preference, right? It actually understands what kind of preference you would like to have. So then it looks into its movie set completely and understands, okay, I have these list of movies which are basically matching his preference. These preferences are not collected during his user activity. These are assumed that user might like it, because we cannot trust the user. So in most of the cases, the user preferences does not reflect his actual preferences. So we rely on the items that we have. So as you can see on the right side, you build a matrix which basically says product 1, product 2, product 3 on your rows, and feature 1, feature 2, feature 3, feature 4, and so on your columns. What does it say? For every product, I'm going to build a feature. For example, here our dimension of a feature set is 4. So for every product, we can define a product in these 4 features. As you can see, it's rated 1, 1, and 4 for the feature or product 1, and for the product 2, it's 1 and 4 for feature 2 or feature 3, and so on. So we see what's the user preferences till now. We see for the feature, he has given 1, 2 rating. For feature 3 has given 1, and feature 4 has given 1. We're going to make a dot product, a simple dot product here, in order to understand which is a product that is very closer to the user. So that's how, this is a very naive way of doing content filtering. If you read more about it, it's much more deeper. So the basic idea is this: for every product, you create a latent features, and then every product, you derive some sort of representations around these features. And for the user, you also derive some representations around these features and the product. And that's how you move forward. Content filtering is something which doesn't last long in a system. It basically targets the initial part of the system user interaction. That's because we do not have enough data to see how a user is actually working on the system or his expectations on the system. We're going to take time in order to gather this information by serving him with the content-based recommendations. Before moving on to collaborative filtering, I want to shed light on user item rating matrix, which is basically a pretty much important concept around the collaborative filtering. So you have seen, this is a very famous algorithm. There are a lot of videos on YouTube. You see on your rows, you have John, Tom, and Alice, and you have 4 movies on top. Well, consider it as A, B, C, and D. So John has given a rating for the movie A, which is Argo here, I guess, as 5, the highest rating that you have given. You see for the John, he has given all of the ratings. That means for the John, we know what he likes, correct? We know what he likes. For Tom, he has never watched Argo. He has never watched a movie B. He has never watched movie C, but he has watched movie D. He has given a very low rating of 2. Okay. For Alice, she has given 4 and 3 for movie A and C. We have missed ratings for this, correct? So collaborative filtering is basically trying to fill these question marks. So what do we get out of this? We will know the preferences of Tom. We will know the preference of Alice for their missing movies that are not present in our data set. We apply the similar way of doing it in our Crystal. We replace movies with the topics that we have. Here, we replace the product with the topics that we basically ask the user to ask. We replace the features that we have derived from looking into our topics, right? So the idea is same, but the data that feeds in changes here. So collaborative filtering basically works like this. On your right side, you see a picture, a user A, looking at you're looking at the matrix, user item matrix. I see that you have 4 similar users for user A. For the first user, there are 3 items. There are 3 items that has been preferred by the user 1. For the user 2, there are another 3 items. And you see, out of all the users have predictor, all the users have preference to a jersey, which is a shirt kind of a thing here. And we basically count how many times this particular product has been, been preferred by all these similar users to the particular user that we're looking at. We basically count and rank all these users, and we pick the winner. Here you see the winner is the jersey product that the user A might like. So we're gonna give the recommendations in this order. As I said, products are here only for your understanding and to visualize in bigger. On the other side, we use topics in place of products here. The next one, which I said, it's more of a crystal thing. I'm going to give a short introduction on embedding space. So what's an embedding space? Why are we actually saying this? So in NLP, what we have is we have text representations. Algorithms or matrices doesn't understand English language. They need a conversion from alphabets, characters to numbers. So embedding is a technique which basically converts this text into vectors or some series of numbers. For example, you see the king, queen, man, woman plotted on this 2D vector space. The meaning of king and the meaning of queen and the context they are used, they are used together, right? So the embedding space ensures that the representations are learned in such a way that the context and the meaning of the word remains the same. How do we actually measure whether these 2 words are similar or not? We do a cosine similarity. You would have known the cosine similarity formula from your bachelor's or from your +1 and +2. It's a very same formula that we use. So what do we do here? From our systems, we have a corpus of users, their user IDs, and some of the features that we believe they are important for the user. For example, its location. For example, what kind of device, whether the user is using, is it a tablet or a desktop or a mobile phone? What kind of interaction is having to the system, whether it's by text-based or by speech-based. We also feed in the item corpus. The item corpus, again, here consists of the topics and its features. We train a deep neural network here. We extract more features out of it. We construct item embeddings and the user embeddings. What are item embeddings? Representations for the topics that we have. What are user embeddings? The representations that are learned from the user. So every interaction from the user to the system are measured in a conversation based. Imagine you are using a WhatsApp. You're talking to your friend. We window every 15-minute exchange of message as a conversation, and then we tag them as one single conversation, and then we move on. Similar kind of a thing we happen in Crystal. We construct these user embeddings. We store them. The item embeddings are stored in the nearest neighbor DB. So this DB basically maintains the representations of all the topics that you are actually populating during the conversation with the user. And the user would have created his embeddings, his footprint on the system. We also derive some sort of embeddings from them. And we're going to look for our nearest embedding in the DB that we have stored. And yes, we will have a rank of topics, which is ranked from the strongest correlation to the least correlation. And boom, we give the recommendations in that way. So what's difference between having a collaborative or a content-based filtering there is, we rely on both here. We rely on the content, we rely on the collaborative side of it. A collaborative side, when I mean, we rely on the users' embeddings as well. What the major difference here is, we take into account the text information or the contextual information about the user feeding into the system. Unlike in Alexa or unlike in Amazon, the text is not taken into consideration. Here, the text is taken into consideration. That's how we generate recommendations here. As I said, there is an advanced algorithm. Currently, Netflix uses this. This is called multi-arm bandits. There are a lot of lectures from MIT. You guys can look it online on YouTube. The basic idea about this is as follows. Consider you have a slot machines, right? And you want to maximize your win. Okay. So what are you going to do? Usually, I have 100 rupees with me, and every time subscribing to a slot machine for one single shot takes me 5 rupees. Consider this. I want to maximize my profit. What do? I apply some strategies. Maybe I have I take 1 week of time. I go daily to one of the slot machines and try my luck. After 1 week, I can have an idea about, okay, which of the slot machine gave me a maximum reward. You basically construct a PDF of every slot machine in terms of profit, correct? So these are the strategies that exist in order to balance exploration and exploitation. Exploration phase is basically serving you with recommendations that may or may not be in line with your preferences, because the system is on an exploration phase. As soon as you basically guide the system by clicking it, or by watching a movie, or by listening to that song, or by asking a topic that the system is showing you, you basically narrow down the exploration phase. On the exploitation phase, you have already built some of the knowledge of the user, and you give this particular information. There are some variants which actually does this idea, which is epsilon gradient and upper confidence bound. Look into these algorithms; they're pretty much interesting. Also look into the Netflix engineering block. We are still developing our engineering block. It's not live yet. Let's hope we're going to do it soon. On the Netflix, you're going to see these particular ideas about how actually they are actually benefiting from this particular algorithm. It's a very basic thing in human nature, derived from the human nature. You explore first and then you exploit, or you directly exploit. It's all thought process. So they do all these things, always exploration or always exploitation, or they strike a balance between exploration and exploitation. These are some buzzing words that you listen into this algorithm, and this is working pretty well in large systems where you have millions of items to show it to the user. This doesn't fit our systems because we have user configured topics. They do not actually increase more than 1,000 or 15. We never had more than 1,000 topics that are configured. Unlike Netflix and Amazon, you have products coming up daily, and all around the globe, the product space is huge. Okay, Jairam, you told us how do you run all these algorithms? How do you know whether this is working or not? There are a couple of evaluation metrics here, which we actually tend to monitor it, which we call mean average precision and the coverage. You would have heard about F1 score, accuracy in your systems, or precision or recall, or a combination of both, or some other metrics or custom metrics that you want to fit into your use case. What we target here is the mean average precision, which is basically it evaluates on the ranking part. So you can see the query 1, the green and red boxes. So you have given 6 predictions, and the user has selected the green ones. Okay. So you see that user has selected 3 out of 6. You make that calculation. While the user has selected another 3 in the query 2, but you see the greens are much on the top. On the query 1, the greens are equi-spaced, and one of the green is at the last, right? So our recommendations should actually maximize in pushing the items that are very relevant to the user on the top, because user may not like it to look into the bottom of the recommendation and say, okay, this is my liking, but we want to maximize the other way around. So that's how mean average precision is calculated. Coverage is basically a term that we use here in Crystal. We want to see out of how many configured topics that the user has configured, and how many out of them actually asked by the user. We want to monitor whether the user is being active or passive. So we do these evaluations at the both offline and online level in order to measure the user satisfaction onto the system that we have. Okay, that's the end. On the summary, we're going to summarize the following. You would have seen augmented intelligence is now being adapted. What I see around, even in the entrepreneurial scope in Europe, everybody wants to make the most of what they have. They are not looking for new data set. They are not looking for new skills, new people. They want to automate things that they already have. ML AI is booming to address this particular problem. Every company can adapt to this particular solution. They can also have a recommendation systems, which is crucial for user engagement rate. And there are a lot of companies which are relying on the data set that they have in legacy. For example, there are companies, if you know a company called Sky, you would have, in India, they are partnering with Tata. You see Tata Sky. The Sky is a multimedia and a telecommunication provider. Sky had hell lots of data, and they have not started an ML team since till 2015. So whatever you watch, this happens in Europe, whatever you watch on Sky, whatever content, I mean, if you watch even a normal channel, every analytics is taken into consideration. Every signal generated by the user is taken into consideration to give him an offer or a promotion in the next months. This is happening at all levels. Sky is just an example. It's happening in insurance companies. It's happening in medical field. It's happening in robotics. It's happening everywhere. So ML and AI are some crucial things that that I am currently stressing on. I'm actually working in this in deep, and we are researching on the recommended systems. Well, as I said, all my experiences on my journey are subjective. All the decisions that I've taken are purely based upon the awareness that I had during my time. And yeah, the turns that I've taken from ECE to CSE, I don't call it as a transition. It is a need. I have friends from the US, Germany, and even in Singapore. All these guys are working for companies. I have like this one. There is an Xilinx, yeah, Xilinx, AMS, and Apple. These are semiconductor companies. They do semiconductor as well. These guys, they rely not only on the theoretical knowledge or the electronics background that you have. They need programming skills in order to make the designs possible. You create a circuit, you make a, PCB manufacturing is a very costly affair. You need to design it and you need to test it, correct? How do you test it? How do you design it? You have to interact with the computer systems. People are asking for automation about design. You can't sit down, okay, I need a week to design this particular IC chip, and then we're gonna make it to production. Okay, after 2 months, you basically have tested it. How about I automate the entire process of designing and testing? So that's where the coding skills come into picture. I've realized in Juniper, wherein we need to write Python code in order to assess the network network health in our company. The packet transfers, the content in the packet. How do you want to separate the video packets from the audio packets? How do you do this? All these things require coding skills. So that is when I realized coding skills is much more important. I guess you would have already aware of how strong is a career with having a coding skills. The best part of EC here is you are strong in your domain of telecommunications, signals and systems, and wireless networks.
and then you're also strong in the coding. This is a very deadly combination. You are hired in, you have hell loads of opportunities, and you can see the entire hardware and software architectures in your mind. You basically develop a lot of engineering mindset. Having said that, I'm going to conclude the session. The floor is open for Q&A.
I guess we have a few questions, and should I just read them out and you can answer them?
Yeah, sure.
Sure. So one question says, what kind of model or algorithm you put the data through? Like, I guess they're talking about your own company.
So we have not single model. We have a lot of models. Few of the models targeting the NLP. Models that I'm working on targeting on the user behavior. There are models that are working on the time series forecasting. There are models that are working on the alerting. So for the NLP, what do? If you have heard about BiLSTMs, they are bidirectional encoders. They basically maintain the memory. So we use BiLSTMs for our entity recognition within the text. And for the recommendations, we use an ensemble way of models. We use popularity. We use collaborative filtering. We use content filtering, as I said. We use the user embeddings that I mentioned. And for the forecasting, we use gradient boost. There is another naive way of, it's called ARIMA, which is basically an autoregressive model. We also use autocorrelation models in order to make the time series analysis.
Awesome.
Yeah, I hope that answers your question. I mean, there are a lot of models. Each and every model serves the one need of the business.
So yeah, one question says, what do you suggest us to do? Like for EC people, like what is the path you want us to follow?
I mean, as I said, it's purely subjective, Naveen. See, first focus on what kind of field that you want to work on. ECE takes two different ways: signal analysis and electronics purely, right? Figure out which part of the subjects interests you more, which part of the subjects gives you a lot of interest and a lot of confidence. To give you an heads up there on the market side, semiconductor industries, electronics industry, electronic component industries, they are pretty few. They are mostly in the US. And I mean, as you know, Taiwan is a manufacturer of all these things. Even China and Taiwan, you will have all these opportunities. Even in India, you have BHEL. And I guess Bell or BHEL, one of them. But the opportunities on the communication sides are more than the opportunities on the electronic side. That's one of the major reasons why I choose to move much more deeper into communications, seeing the level of opportunities. I want you guys to not to just focus on the theoretical, always choose subjects or concepts that have practical exposure. At the end of four years, you must be able to build something. It could be a robot. It could be a small algorithm which basically listens to the Wi-Fi packets and tells you that who is actually watching YouTube all the time in your campus. All these small projects, handy projects, do them, get those ideas, make a practical exposure. That's the most stress. I would stress more on that.
Great. So we have one more question, which is, what all libraries do you use? TensorFlow?
Yeah,
PyTorch?
we use TensorFlow. Of course, Keras is under TensorFlow now. We use TensorFlow and Keras layers for our deep learning models. We do not use PyTorch.
Awesome. So yeah, if you don't have any other questions, please, you can take 2 more minutes. If you have any other questions, just put it in the Q&A, and then you can go from there.
Yeah, before people put more questions there, for the next coming years, I hope most of you people are in third year and fourth years, I guess, maybe the majority audience here. In any ways, focus on, as I say, focus on the practical knowledge. Attend lots of workshops, make a lot of prototypes. Always try to understand what the professor is trying to teach you in terms of business need and what's in the market. Be updated yourself with the technologies. Please do attend a lot of developer summits, or Apple actually gives every year, Google gives every year. Do attend them online. See them what they're talking about and what's the business problem that they're addressing. Keep your LinkedIn profile up to date. Have some good amount of projects. Keep looking for an opportunity. Could be an internship. Could be a job. If you want to be an entrepreneur, do not hesitate. Start working on it. The next age is going to be a startup age. I mean, it's already there in India. I mean, when I was in 2014, Ola did not start. Ola was actually starting. I did not start full-fledgedly. We had few friends who were hired for Ola. It was a service which was only provided in Bangalore. It did not had any reach. Their systems broke down if they had more than 100 users. They had these problems. They started building it. They had this vision, and now Ola is a big company. Even Ola is now starting their services in UK. Believe in your idea. Do talk to your professors. Do reach out them for more suggestions. Do reach out for people in LinkedIn who are already working in the field of your interest. You can build a lot of ideas. There are people for you to help and invest in your idea. That's the entrepreneurial part of it. And for the jobs and for the internships, keep looking on the LinkedIn. You can also drop me your resume. We offer internships virtually. Internships fully remote, not virtually actually. Sorry. We can hire you from India as well. If you feel like you have a strong background, we will definitely want to talk with you and exchange information.
Awesome. Any other questions, guys? Like, obviously, you can contact Jairam sir directly on LinkedIn. And then, as he said, do share your resume if you feel so. Like, if you would want to pursue a career in machine learning, and if you feel that your current interest aligns with the company's interest, so please do that. And since there are no more questions, so first of all, thank you, sir, for I know it's around 5 to 6 a.m. out there, so really appreciate it for just coming on here and giving such a great talk. First of all, so yeah, really thanks for that, and thank you to all the audience for staying for 1 hour, I guess. So it's a Sunday, but yeah. So hope everyone learned something, and it was a wonderful webinar. So thank you for that. And Sunil, just you can give out the form in the chat box. So guys, just fill the form up so that you can get your certificate. It's just a small 10 question and answer type objective. So it's going to be really simple. So just complete it. Anything else, Jairam sir or Sunil, you want to add? Anything?
Thank you so much, Jairam sir, for the talk. It is really amazing, and you have given very good suggestions for the ECA students. It is very nice to hear about, and I am thinking the audience will also enhance their career by listening to your suggestions and tips. Thank you so much.
Can we end it?
Yeah, thank you. Thank you. It's so great to be here, and I looking forward for more questions on LinkedIn. And thanks for all the coordination, Naveen and Sunil. Thank you.
Thank you so very much for doing this.
Thank you.
So guys, we'll end this right now, and you can fill the form, and then the certificate would be mailed to you. Thank you everyone for joining, and thank you. We can end it.
Thank you.